Hey, in this video we're going to be talking about logarithm properties. So right here I have three that are listed out. One of them is going to be stated as the product rule, the second one will be stated as the quotient rule, and the third one's going to be listed as the power rule. Now I'm going to go ahead and talk to you about what they do and how to actually see them. So what they actually do is whenever we see a product between two variables, we go ahead and say, okay, that becomes addition. So as you see in the first line, we go ahead and see that x and y are multiplying, so that now we get to go ahead and place a plus sign in between our two variables. So now we have log base a with an argument of x plus log base a with an argument of y. You're going to use the same base for both variables, so just go ahead and keep on repeating to write the log a. Now when we go ahead and look at number 2, we see the quotient. So the quotient rule leads us to become subtraction. So anytime we see anything that's dividing, so anytime we see a fraction with a logarithm, we can go ahead and say that becomes subtraction. So anytime we see division, we're going to think subtraction. And anytime I see product or multiplication, I'm going to go ahead and see addition. Now on the third rule, what we're going to do is anytime that you see a power or something raised to a variable raised to a number, we're going to go ahead and pull that up front. So that the power rule allows us to bring powers up to the front. This will help us to either equate problems or overall just be able to modify our problems or adjust our problems accordingly to what we need. So down low at the bottom, we have some examples, and we're going to use those properties accordingly. So we're going to go ahead and talk about it here using this example. So right now there isn't parentheses around these examples, as you can see, but if you feel more comfortable placing parentheses around it, I would go ahead and place parentheses around it. That way it makes it easier to tell you like what you're doing. So I noticed right away, and when you're attacking these or when you're looking at properties of logarithms and you're wanting to expand them, so that's what we're doing here. We're expanding the logarithms. So the questions will typically ask you to expand this set of logarithms or to reduce it or to shrink it. So when we expand it, it's gonna be a bigger logarithm, and then if we're gonna shrink it, it's gonna turn down to 1. So the first thing we notice here is that the 6 and x are multiplying, and you can kind of attack them differently according to like what you see. So right now I'm focusing on the 6 and x. You could see the 6x and the y as subtraction, so either one you feel more comfortable with right away. So I notice that we see the 6 and the x are multiplying, so I can go ahead and say log base 2 of 6 plus log base 2 of x. Now we can use that as a parentheses because that's what occurred, and then this would still be dividing by log base 2 of y. Now on the next step, you'll see that we're going to go ahead and change. Whenever I saw division, I can go ahead and say it becomes subtraction. So I would really encourage using parentheses around these, because overall you're going to start to notice that negatives are going to be missed. So you'd rather start using the parentheses early. So we know that we have log base 2 of 6 plus log base 2 of x, but we now get to say minus log base 2 of y in parentheses. And that would be the final answer for this one. This one's going to be very similar, so I'm going to do it the other way now. So I can go ahead and say, well, log base 3 of 4p, and I'm going to say minus log base 3 of q. So I'm noticing that the division is occurring first, and then now I can multiply those two, which multiplication changes to addition. So what we're trying to notice here is that your overall, anything that looks like they're multiplying, so whether it be a number times a variable or two variables times each other, you want to go ahead and just state with logarithms, we get to just move them. We don't need solutions, we just need to expand them. So and let me correct myself more. we don't need values. We just need to expand the logarithms out more. So what we're going to go ahead and do is say log base 3 of 4 plus log base 3 of p minus log base 3 of y. Sorry, q. Good. So that would be the overall answer for that one. And you're going to see here I'm going to apply properties of power. On the other previous ones I didn't need it, and I'm going to go ahead and talk about that just for a little bit. So what we're going to do is I'm going to jump straight into it. I noticed that the 5 is multiplying by the square root of 7, and I noticed that it's dividing by 3. So I'm going to jump straight into it and say, I can say log base 5 of 5 plus log base 5 of the square root of 7 minus log base 5 3. And then there's my parentheses. Okay, so the last piece to this one's not complete, and it's for one reason. So I'm going to explain just really quickly what it would be. So anytime I see a square root, I need to make sure I raise it to a power. So it's going to be a raised to the power of 1/2. There will be another video explaining that in case if you need to review a little bit of the power properties of exponents. So the way that we're going to go ahead and write this is log base 5 of 5 plus log base 5 of 7 to the 1/2 minus log base 5 of 3. Now that allows us to go ahead and write it as log base 5 of 5 plus 1/2 log base 5 of 7 minus log base 5 of 3. That would be your final answer. I know I kind of squished it in there, and I'm going to do some more videos of this, but this is just the beginning aspect of it. Thanks y'all for watching.